once again and welcome to lesson 5. All right. So before we start with our lesson or our presentation for lesson 5, I just want us to open TIA portal. Okay. I hope you guys are enjoying our videos and you are subscribing to our YouTube channel. Okay, so there we go. So I just want us to open this first project of ours. All right. And I want us to start programming. Open the main block. Okay, there we go. So this is where we left off previously. All right, so we're going to be writing a program again on the same block, which is this main OB1 programming block. Okay, I want us to delete both networks, network 1 and network 2. So I want us to delete these instructions. Okay, so that we can write new instructions based on the presentation for lesson 5. Okay, so let's go ahead and do that. So I'm going to delete network 1. I'm also going to delete that network. Okay, then I'm going to stop here. I'm going to minimize and start the presentation for lesson 5. Okay, all right. So this is lesson 5 programming exercise. So what is it we are doing? It goes like this. When the start button is activated, motor A starts running immediately. So there's one start button. When it's activated, motor A starts running immediately. 10 seconds after motor A has started, motor B starts running automatically. So you activate the start button, motor A starts running immediately. 10 seconds later, after motor A has started, motor B will start running automatically. So we can go and say we need a delay on timer to activate motor B. So today we're going to be adding a delay on timer onto our project such that when we press that button, motor A starts rotating. 10 seconds later, motor B will start rotating automatically. Okay. If you stop motor A, both motors will stop. All right. So we can say, we can make an example of two conveyors, conveyor A and conveyor B, where if conveyor A has started rotating, 10 seconds after it has started rotating, conveyor B will be rotating automatically. But if you stop conveyor A, conveyor B will also stop. Okay. If the emergency stop push button is activated, both motors will stop rotating at any given time, at any given moment. Okay, so we also have an additional emergency stop push button, not push button, emergency stop button or switch, that when it's activated, both motors will stop rotating immediately at any given time. All right. In this exercise, again, we will not consider overload settings and motor temperature. Okay, so let's go ahead and start programming. Okay, we can actually minimize that window and open our software. Okay, remember we still have those tags for this project of ours. Still have those motor sequence tags. We still have these tags here. These tags here. See these tags here. Okay, we still have the tags. We can still use them in this project. Okay, but we're going to add and edit and make new changes such that it suits the instructions. Okay, so we can go ahead and write that comment there and say motor say motor A control, something like that. Okay, so here I want us to start motor A like we did before. So I'm going to add, in this case, let me add a stop push button, an e-stop, a start push button, and also add a coil for that motor, for motor A. Okay, so this one represents, say, a start push button, no, a stop push button, a stop push button, which is stop A in this case, stop motor A. And then this one here represents, say, a start push button for motor A. That one is motor A. Okay. What about this one here? This will be my emissions stop. Okay. Then I'm going to give it an address, a brand new address, which is not on the text. Okay. Then you're going to learn something new again. If you were to type in an address there, it will also be added on the text. Let's give it a name. Let's give it an address. Let's go say it's I, say 0.7. Okay, that is my e-stop. Then I'm gonna rename the tag. See, this tag 1. I'm gonna rename it. So right click on it and rename the tag. And I'm gonna give it a name E. Say stop. I give it a name e-stop and change the name. So this is our e-stop now. Okay. So as it is now, we can start this motor and stop this motor, but it won't retain itself. So we still need to create that branch again to retain current all the time. We have to do that. All right. Can do this. Then this is MA for the retainer. Okay. So we can start this motor. The motor starts rotating. If you press the stop push button, this motor will stop rotating. If you press the e-stop, this motor will stop rotating. Okay. Now, what about now the new scenario where we want to add a timer such that after 10 seconds, motor B will start rotating automatically. Okay. So this will be a motor B control. All right. It goes like this. So here we need to activate a delay on timer such that when motor A is activated or is energized, the timer is also energized. The timer starts counting from 1 to 10 seconds. Thereafter, motor A will start rotating. Okay, so we go again to basic instructions. We go to timer operations. We highlight there. We go to timer operations and then we look for a delay on timer. We're gonna use IEC timers for now. So you're gonna pick this one, generate an on delay. Okay, as you can see there. T on means timer on. Delays the setting of the Q output by the programmed time PT. Okay, it can be used in S700, S7400. So you can actually drag and drop that block. Let's see what's going to happen when I do that. Okay. All right. So when I drag and drop that delay on timer, it asks me a question. It says data block. So it comes with a data block, an instant data block, as you can read there. The called function block saves its data in its own instance data block. the call function block saves its data in its own instance data block. Sorry about that. Okay. So what happens here? If you call this IEC timer, it is actually a function block that has been created for us that we can use, but it comes in with an instance data block where the data for this function block is saved. Okay. So do you want that? This is what we want. Press OK. As you can see, here is my IEC timer 0dp. So my dp1 here, the data block is there for this particular function block. Remember, this timer T on, this delay on timer, is a function block that is being given to us by Siemens system engineers. So they created for us so that you can use it. Okay. Now, PT is your preset time now. Is the input time. So the data type for this input is time. The data type for this input is time. Okay. What is ET? Your ET is your output. Also the data type there is time. Okay. The Q is the output in this case. So if you want to activate something, you're gonna have to wire it here at the output. If you want to activate a timer, like for instance in this case, because I want this to depend on motor A. So if motor A is energized, I want us to energize this timer also. Okay, so I'm going to need a normal open from motor A in this case. Okay, I hope you guys are following. So if motor A is energized, this normal close, this normal open is going to become normally closed. Then this timer is going to start counting up to 10 seconds. So my preset time here, I'm going to put 10s for 10 seconds. Okay, I hope you guys are following. All right. And then I'm going to be wiring a coil there. Okay. I'm going to be wiring a coil there. And then this coil will be MA. MB in this case. It will be motor B, such that when this motor has started running, it will energize the timer. Then this motor will wait for 10 seconds here. Then it will start rotating automatically. So, okay. But I also want to make sure that when an e-stop is pressed, both motors will stop. Okay. So I'm also going to wire the same e-stop here. Okay. The same e-stop. Okay. But this is just for safety, because in any case, this delay on timer, it can never work without power. Okay, those who are electricians and those who maybe guys are engineers, technicians, you know how to wire a delay on timer. Okay, so if you wire it up, it only works, it only counts. Okay, it only counts, it only times when the coil is energized. As soon as you take away power from it, it stops whatever it's doing. So this is, I'm just putting in this e-stop, but in fact I don't even need it, because this motor depends on this timer, and then there's a dependence again that says this timer will never run unless this motor is energized. But I'm just putting it there for safety purposes. Okay, I hope it's fine with you, because it depends on this contact. As long as this contact is open, this timer will never count, and it will never time, and at the same time this motor will never run. I hope you guys are happy with that. Okay, now we can go ahead and actually start simulating. Okay, let's do that. Now, before we do that, let's check our system blocks and see if that block has been added there. So you can see there that DB1, the data block for this timer function is there. Okay, and it's under system blocks because it's what is being given to us by Siemens software. We didn't create this function block. All right, I hope you guys understand. We can actually change and rename this data block and call it, say, let's call it timer 1, T1. Let's call it T1. It's not a problem. We can call it T1. Okay, let's call it T1. All right, it's not a problem. We can do that. So we can save the project. We can compile the project and see if there are any errors. Okay, and then errors. Let's check. Do we have any errors? All right. It says inputs or outputs are used that do not exist in the configured hardware. So this is just a warning. All right. What is it that we're going to have to do? We're going to have to download this into our hardware configuration. We're going to have to save and download. Okay, but before we do that, we need to start the simulator. All right. Remember, we added a timer. We also added that normally open, that normally closed switch for the e-stop. All right. So this is our simulator. We need to update that, and then we're going to have to update the PLC. Let's do that. Loading the configuration. As you can see now, there are no errors. There are no warnings because we have just downloaded this onto our PLC. So it knows about our changes. Okay. So what is it we're going to do now? We're going to be running this and check if it works. Okay, let's do this. Where's my simulator? Let me drag and clean up here, then pull up the simulator again. So as we can see here, our start button is I0.1, and then our e-stop is I0.7, and then our stop button is I0.2, and then Q0.1 is motor A, Q0.2, which is this one, is motor B. Okay, let's go ahead and do that. But before we do that, let's put the PLC in, CPU in run mode. We click there. Okay, the PLC is happy and it's now in run mode. And then we can also monitor our networks. We can click here to the main with classes. Then we can monitor this main OB1. You can see now it's being monitored. Okay, there we go. Let me pull up my simulator again. Then we can start playing around with this. So I'm going to go ahead and start motor A by pressing this push button, which is I0.1. Press I0.1. Then motor A is starting, and then you can see the timer is counting. It's now 3 seconds, 4 seconds, 5 seconds, 7 seconds, 8 seconds, 9 seconds, 10 seconds. Motor B is also running. As you can see, motor A, which is I0.1, is running. Motor 2 and motor B, which is I0.2, is also running. Okay, if I press the stop push button, which is I0.2 in this case, both motors will stop, as you can see. Let me go ahead and run again. That button, you can see it's counting 3 seconds, 4 seconds, 5 seconds, 6 seconds, 7 seconds, 8 seconds, 9 seconds, 10 seconds. There you go. Both motors are running. Okay. Both motors are running. What will happen if I press the e-stop, which is I0.7? This is what's going to happen. Both motors stop. Okay, happiness. Okay, you can do it again. I just want to pull up this window here so that you can also check what's happening here. Okay, there we go. Let me try this and put it here, and then again we can start I 0.1. It's counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Go. Okay, both motors are running. Okay, so this is how you want to wire up and use your delay on timer. I hope you guys enjoyed this video, and God bless you. Stay at home.